Hi guys, so I just wanted to go over another way to factor difference of perfect squares. And again, the same thing you need your list of perfect squares, 1, 4, 9, 16, 25, 36, 49, and so on. And how do I know that these are perfect squares? 1 times 1 is 1, 2 times 2 is 4. What if I wanted to know that 81 is the perfect square of what number? Well, I can find 81 and count in 1, 2, 3, 4, 5, 6, 7, 8, 9. So 81 is the perfect square of 9. Okay. Don't forget that your difference of perfect squares rule is a squared minus b squared equals a plus b times a minus b. So you need to have a minus sign and you need to have two perfect squares. So let's look at number 1 here. And I want to know, is a squared a perfect square? Yes, because don't forget there's that invisible 1. Is 1 a perfect square? Yes. So is 16 a perfect square? Yes, it's on my list. So here, the square root of 1 is 1. The square root of a squared is a. The square root of 16 is 4. So I have my a, I have my b, a minus 4 or a plus 4, it doesn't matter, times a minus 4. Okay, let's look at the next one here. Are these perfect squares? Well, is 25 a perfect square? Is it on my list? Yes. Is a squared a perfect square? Yes, because we know that it's even. The exponent is even. Is 9 a perfect square? Yes, it's on my list. So what squared gives me 25? A squared. What squared gives me 9? I have a minus sign. So the square root of 25 is 5. The square root of a squared is a. The square root of 9 is 3, and so I have 5a plus 3 times 5a minus 3. All right, let's look here. Is 18k squared a perfect square? Is 18 on my list? No. Is 32 on my list? No. But what do I know about 18 and 32? Well, there's a GCF, and we always need to look for a GCF. So I'm factoring out my GCF, which is 2. 18 divided by 2 is 9. So I have 9k squared minus 16. Now I look in the inside. This 2, again, means nothing to me until the very end. So now I'm going to look on the inside, and I'm going to say, is 9k squared a perfect square? Well, 9 is on my list, and 2 is an even exponent, so yes. Do I have a minus sign? Yes. Is 16 a perfect square? Yes. So now the square root of 9 is 3. The square root of k squared is k. The square root of 16 is 4. So I have 3k plus 4 and 3k minus 4. And don't forget, we need to drop down the 2. This is almost the same kind of problem, except now I have an x squared and a y squared. Well, we're still going to look at the same thing. Do I have a GCF? No. Is 4x squared a perfect square? Well, 4 is on my list and x squared is even, so yes. I have a minus sign. Is 25 on my list? Yes. Is my exponent even? Yes. So what times itself gives me 4? 2. What times itself gives me x squared? X. Here, what times itself gives me 25? 5. What times itself gives me y squared? Y. So I have 2x plus 5y times 2x minus 5y. All right, so this one, are these numbers perfect squares? No, but do I have a GCF? Yes, my GCF is 5. So I'm going to take that out. So I have 4x squared minus 9y squared. Now, is my inside a difference of perfect squares? Do I have a minus sign? Yes. Is 4 a perfect square? Yes. Is x squared a perfect square? It is. Is 9 a perfect square? It is. Is y squared a perfect square? Yes. So I have what squared is going to give me 4x squared? Well, 2x times 2x. What squared is going to give me 9y squared? 3y times 3y. So I have 2x minus 3y times 2x plus 3y, and I have to drop down the 5. There we go. Oh, I need the plus sign here. And remember, it doesn't matter which one comes first, the plus or the minus. All right, so here, look at this. Do I have a difference of perfect squares? Well, is 25 on my list? Yes. Is p squared a perfect square? Yes. Is 4 on my list? Yes. But do I have a minus sign? No. This is not a difference of perfect squares. This is not factorable. All right. Have fun with the lesson, guys.